Well, this is a customer's Perses. We're going to disassemble it and get it ready for brushless motors and the upgrade kit. Now when you separate the halves, try to keep everything on the bottom half if you can. There's bound to be some screws that are still hanging on. And if you can, keep all the screws in the top half and just set that aside. So we're going to be removing a lot of this stuff here. This whole battery well is coming out. The motors are coming out. All the wiring is coming out. We'll start by taking the trigger. Whole assembly should come out. Take the front end off. Okay, so now we have the bottom half separated. Now we're going to remove this the hopper sensor. It's not really necessary. I think a lot of people take them off anyways. But it won't let the gun run without the hopper on. That's what it's for. These parts won't be necessary in the upgrade. Unless you want to keep them, that's up to you. Okay, I think now the next thing we'll take is take the motors out. So the flywheels are pressed in here onto the shafts. I think we'll take this cover off. I'm going to put these screws back in. I'm just getting pretty many screws here to remember where they go. So we're gonna pop these flywheels off. See, when they put them on there, it created stress marks from the pressing them in. So I'm gonna push these out with a pin. Push the motor down in. Flywheel should sit down on the base. Push the motor out. I'm gonna do that on drill press. I just put the pin in, drill press, and press down on this. See if I can support it in some way. Okay, well, there's probably a bunch of different methods to get these out of here, but they're glued in. They also have foam around there, so there's holds the motor in. When I push the shaft out on this side, push the bottom end of the motor out a little bit. I don't plan on using the motors anyhow, so we're just going to get them out basically any way we can. Alright, so only thing we need here out of this is possibly the switches and this part here, the feeder. So we need to get rid of all this electronics, and we'll do that with a soldering iron to remove that. These things glued in on both sides. Alright, so this is heated up, so we're just going to try to do the outside here first. Pull that off just like that, and do the other side as well. You're just going to heat on that ball of solder and keep applying pressure until it comes off. Like that. And you're just going to heat this up here and remove this as well. Left a little bit of a solder blob on there, but I can get that all with the Dremel. Best not heat this up any more than you have to. You just don't want anything melting in there with the feeder mechanism. We're gonna have to disassemble this anyhow because there's a safety gear inside here, and what it does is if the motor's spinning and the feeder stops, it will slip between the two and save the motor or save your wiring, because it would automatically heat up right away. But when it does that, once it starts slipping, it actually wears. So once it starts slipping, it just continues to slip more and more and more until that gear is completely rounded out, and then your feeder doesn't work at all. So what we're going to do is we're going to disassemble this. We're going to put two pins in the safety gear, so it's a direct connection between the two. And then you just have to realize what you're, don't hold on the trigger when the balls are not coming out. Don't hold on the feeder trigger when the balls are not coming out the front of the gun, unless the gun is empty. So if you got a jam in there, don't continue to hold on the trigger, because there's a few things that are going to happen. You're either going to strip the gears, you're going to burn the motor out, you're going to overheat the wires. Any number of those things will probably ruin your day. So this part here, the two motors, I think we have 3 switches here. Okay, battery's dead, I guess. We supply you with switches, so this entire section here will not be used. So we'll put those on the not used parts list, along with the stuff here. We'll probably just the insides. I'll probably keep the cover. I will leave it there for right now. Alright, so the next thing we're going to do is we're going to disassemble this and pin the safety gear together. Now this is a little bit tricky because the way this is situated, there's pins that go completely through here and lock into this boss on the outside. So when you do this, you want to get this outside cover off, and you want to keep the gears on this side of the mechanism. So if you at all possible, this one is always going to tilt because it has to be in here and the belt is pulling on it. So now you can see all the gears came out on the inside, but this shaft stayed on the left side. That's fine. It's not a big deal. The one that we're really interested in is down inside here. So what we're gonna do is gonna take that guy off there, put him over here so we knew where it went. This guy off here, and that goes in that spot there. This guy here goes in there, the other way. Okay, and then you can probably remove the motor. And these are the two gears that we're worried about. This is the safety mechanism in there, and all it is this gear on this side has ID with a whole bunch of little notches in it, and this side has basically a spring-loaded piece that has 3 notches on the top and 3 notches on the bottom, so that when this locks up and this continues, because this is attached to the motor, those 3 notches, because there's a groove down inside there, there's a void, they will push down and release connection between the two. But like I said, if you're going for all-out power, you don't want your feeder slipping, because like I said, once it starts slipping, it will continue to slip and it will continue to get worse, because you wind up rounding these pins, these 3 notches, or whatever you want to call them, off. So what we're going to do is we're going to take this, put a pin through here, through there, and into that, so that these two become one gear and they're not able to slip. So we're just going to clean off the grease. So we can work with them a little bit cleaner and see what we're doing. So you can do this a number of ways, or not do it. It's entirely up to you. This is optional. I did it to my gun. I'm doing it to this one because basically I know when I'm pushing the gun, doing different trials and tests with motors and flywheels and whatnot, it's going to put added stress on the feeder, because we're trying to because I'm also including in this PWM for the feeder motor. So you can and a voltage regulator, so we'll ramp up the voltage to unusually high level for this motor, but this motor is able to take it. It's a decent motor. I mean, it's fairly cheap, but I've been running mine for almost a year or something now, and I haven't burned the motor out, and I haven't stripped the gears. Other than the initial time, I did strip the gears, and this is what led me to having to fix the issue. So I also, when I do this, I'll put some glue in between the two of them as well, because the pins work well, but you want it to, as best you can with the added, you want it to be one piece as best you can. So there you can see the three parts, and this is the, what I'm calling the safety mechanism. So I'm going to take a pin. This is a steel pin, and get this at online, or you can just use some type of screw, but it's not the right one. Okay, so this fits in on that side like that. This is a 1.5 millimeter pin. You can cut it in a small. You can get a couple pieces out of this. We only need 2 pieces, but we're going to pin it right in this small groove here. One on this side and one on that side. I'm going to drill into this gear and drill into the opposite gear, so that when you push this on there, the pin lines up with the 2 holes. What you don't want to do is you don't want to go all the way through this gear, and you don't want to go all the way through the other gear. You want that pin to float in between the 2 gears. So it has to be small, because the distance between these 2 gears in total is only 5/16 of an inch. So your length of your pin should be around 200 thousandths, 200 to 225 thousandths in length. So you need 2 pieces of this, so you can pin these 2 together. So first of all, we're going to mark the big gear. It's the easy one. The harder one is that. So we put this in there. It doesn't matter where you put it. And you get a pen, or you can also use an awl. Which may be your better choice at this point. And you want to mark that point where you're going to drill. You'll probably never see it, but there's a small mark there. Using an awl, just put a small indentation in. So you got to be careful when you're drilling. You want to drill about in the middle of this. You don't want to get too down far into here, and not necessarily get too up far out of that groove, so that you're drilling in the meat of this boss here. So, and you only want to go in a little bit, like 1/16 of an inch, possibly a little bit longer than that. So I'm going to try to mark it with a pen. The nylon is such a smooth material that not much will write on it or stick on it. These pens are awful big, but I'll give it a shot here. Okay, now I drilled, came out pretty good. This one's a little bit farther out than that one. But what you'll notice is on the other side, it's just poking through. it's not all the way through. That way the pin has no chance to come out on that side. Okay, so I'm going to cut these in around 225 thousandths with the Dremel cutting tool, and just so it doesn't go flying anywhere, I don't cut them all the way through. I cut them until there's this last sliver of metal, and then you can just break them off. I'm going to sand this down with the sander at the ends because it's going to be very sharp. Yeah, so at 226. Let's look. There's enough room that I'm not going to poke through the second gear. So it's exactly what I want. Gonna cut the other pin. I don't think it's going to hurt. I'm going to put this one down inside there along with the other one. Let's see if I can get them to stay. And I got this real small dispenser, and I'll be able to place the glue where I need it. And I'm going to do it around this area here, just over the pins. And I'm going to try to keep it away from this area just because the shaft goes in there, but maybe on the outside of that I'll get a little bit of glue. I'm going to push that in there, make sure I line up the holes. With the grooves, so that I can put the pins in. I'm going to continue to, if I can fill this up with glue. So it's important to fill up those two slots. That's your mechanical connection, which will not allow that gear to crush. Okay, that's what it should look like. My pins were slightly long, pushed through a little bit, but so I'm going to put that in a vise until it dries, at least an hour or so. So these are the two that we want to work on next. I'll get it ready for the motors. There's a bottom plate that we've printed, bolts right onto these 4 sections, but there is some cutting. First go the motors, then the mount, and then the flywheels. Took the two bells off, left a little rim around there. We'll see what else we got to take off. One thing we don't want to do is block the air cooling for the motors. Comes through the bottom, that's not an issue, but also in the bottom of the motor here, there's also air vents where the air cooling has to get in there to cool the motors. So we want to take everything away that we possibly need to, or to get it to work, but we don't want to take away anything we don't have to. But if it's an obstruction to the airflow, well, then we're going to remove it, because it's important that the motors stay cool. So you can just check this, see what we need to do. Just lay it on top there. See, it's very easily to tell that it's going to have to ground both these inner walls off to get the motors in there. Need to trim inside here for the motors. Pretty close though. There you go. It fits right in there now. You can see still a little bit of work needs to be opened up there. You want to give it at least a 1/16 inch of clearance. And it's not there yet, so take a little bit more out of here, a little bit more out of there. Okay, that's pretty good. I'm just going to even it out a little bit, a little more than here. You people who are fussy, that's all I'm doing, is being fussy now. Okay, this is what the finished piece looks like. This was ground away. This was ground away about 1/16 of an inch. I completely take this off. This top was up this high. I completely take this off and ground this back. I had to ground this back a little bit. This part here and this part here wasn't touched. This part wasn't touched. This part wasn't touched. This was all ground away here. Still got a little bit of a lip here, but then it goes down to nothing in there. Same thing on the other side. And these are sloped at an angle, so the wire runs out through there, and it's smoothed out so it doesn't get caught or anything, or you don't want it rubbing against the wires for the motors. So you can see the motors here. It's in like that. Make sure that the wires are coming out the channel, each channel. You see it's going to fit tightly all the way around like this. And you'll be putting the 4 screws in there. And your flywheels will go on, and everything is cut out with a 1/16 of an inch all the way around, so that the flywheels are not touching anything. Height wise, it's good. Just needs to be reassembled. Alright, so we got Got the screws in for the motor mount. And you can see here that I got the proper spacing going around. And I had to cut back on here and here for the flywheels. Alright, they're just on there temporarily, but now we have to match it up with this part here. And when we put it together, you'll see that these parts here also originally matched up with the ones that were here, and this here matched up with those. So since we cut these back, we also have to cut those back as well. So it doesn't go together quite. It's mostly because it's hitting in there in the front where the flywheels are. So we're just going to cut this part back here, this part back here, and then probably similar on this side. You're going to take one flywheel off just so it's easier to see in there exactly where you need to remove material from. You usually can tell when you're just before breaking through. It'll turn like a darker color. You can see the light passing through the thin spots. So you want to be a little careful. If you don't want to break through there, then you can just get an idea of how far to go and then to stop, not to go any further. Yeah, I think I'm going to have to remove this entire corner here. Okay, so I got the flywheels on, they're tight. Can't underestimate the need to have these nuts, either nylon nuts or the nuts that you're using Loctited, because there's a tremendous amount of force here plus vibration. These things tend to shake loose, and you don't want to have your flywheels just spinning in the wind there when you're out in the field. So I put as much torque as I could possibly get on them. Of course, you don't want to put any kind of vice grips or anything like that on these. So I use rubber belting, and also the Allen wrench method is to go up in there and lock inside to the side of the motor, and then when you turn it, you can put force on it. Just want to be careful you don't dig down inside there and mess up the windings when you're doing that. So this is all set. The next thing we got to do is put connectors on the end of these. So I'm just going to use these bullet connectors and shrink wrap tubing. So these wires are really small, and you need to put shrink wrap tubing on this. So the gauge wiring for these motors are small when you compare them to the bullet connector. So when you put the shrink wrap over the top of these, there's some difficulty for the shrink wrap to shrink down all the way down to the insulation. So what I do is I'll put intermediate shrink wrap on, just to give it enough room so that the other shrink wrap slides, or when it when it grabs a hold of it. Alright, so they're all on. We can put the overcoat shrink wrap on after we solder them. So I use a piece of hardwood, just drilled a hole in it. This way, all the heat that you apply to the solder connection goes into the metal and not into the vise that you're holding it. So I kind of leave these lay close by. So once I heat it up, I put the solder in and I can grab one of these and stick it in. Always use flux. If you don't use flux, you're just making it harder on yourself. That's all. You don't need much, just a little bit. I'm waiting for the soldering iron to heat up, and what I'm going to do is I'm just going to take this and hold it down inside there. These are a little short, so just move that up there, I guess. There's a hole in the side of these pulley connectors, and that's to stick your soldering iron in. So it's easier to solder the connector. So you stick your soldering iron in there, it heats up, and you can also take the solder and touch it against the soldering iron. So that's what I tend to do. I tend to stick this in the hole, give it a second or two, and then fill it up with solder. And then I'll take this and once I put the wire inside, I try to hold it in the center. Why? I don't think it matters that much, but it's just a nicer job doing it that way. So make sure you pull on it a little bit, make sure that you got a good connection, and then move on to the next one.